Hello everyone, this is the video presentation of our mini project for SSCC 2841 Physical Chemical Lab 2. We are from Group A501 and the title of our project is Investigation the Effect of Tide on the Mass of Metal Deposited on the Cathode.
Assalamualaikum to Dr. Siti Aminah and Dr. Muhammad Fuad. My name is Khairul and I will present about our mini project. Electrochemistry is a study of a relationship between electrical energy and chemical reactions which take place in a solution at the interface of an electron conductor and an ionic conductor. It involves electron transfer between electrodes through a wire and ion transfer in the electrolyte solution, resulting to an electric current which can be measured by ammeter in the unit of ampere, and voltmeter is used to measure potential difference between those two electrodes. One example of electrochemistry is electroplating, which is a process of deposition of metal with another metal. In medical industry, the equipment often use metal electroplating to improve the biocompatibility of components, especially for implants. Gold, silver, and titanium are commonly used in this industry for their biocompatibility, corrosion resistance, hardness, and wear resistance, all of which are essential for implants and joint replacements. In our experiment, we use magnesium strip at both anode and cathode, where we use 5 different initial mass of magnesium strip for cathode, for each set of time of 5 minutes, 10 minutes, 15 minutes, 20 minutes, and 25 minutes respectively. So we have at the cathode we have different initial mass of the magnesium strip, and then we measure the initial mass, and then we set for the each magnesium strip with 5 minutes, 10 minutes, 15 minutes, 20 minutes, and 25 minutes respectively. We use constant current, concentration and volume of electrolyte, and constant voltage throughout the experiment. The expected half equation is as follows. At the anode, we will have the magnesium turns to Mg2 plus 2 electron, where the magnesium undergoes oxidation and the oxidation number is increased from 0 to 2 plus. And at the cathode, we will have a reduction of magnesium ion, which it will form the neutral magnesium. So we can see the magnesium coordination number is decreased from plus 2 to 0. The objective of this experiment is to investigate the effect of time on mass of deposited metal on the cathode. The manipulated variable is the time in minute, and responding variable is the final mass of cathode Mg strip, magnesium strip. The hypothesis of this experiment is mass of deposited metal on cathode is directly proportional to the time.
For material, we have DC power supply, magnesium electrode, crocodile clip with wires, 100 ml beaker, weight balance, stopwatch, sandpaper, 100 ml measuring cylinder, and ammeter. For chemical, 1 molar magnesium nitrate solution and distilled water. Now we move to procedure. Firstly, 50 ml of 1 molar per decimeter cubic magnesium nitrate solution was measured into 100 ml beaker. Next, the mass of the strip of magnesium metal was measured using weight balance. After that, the wires and crocodile clip was used to connect the cathode to ammeter, the ammeter to the power supply, and the power supply to anode. Then the electrode was placed into the solution. Besides that, the power supply was turned on and the stopwatch was set immediately. After 5 minutes, turn on the power supply, turn off the power supply. The magnesium paper was dried using tissue paper. Last but not least, the cathode was weighed using weight balance. The mass was recorded. Lastly, the experiment was repeated 4 more times using the time of 10, 15, 20, and 25 minutes.
This is the result and data analysis of this experiment. From the result data, we can note that the time of the electrolysis increased, the mass of the cathode also increased. This also can be supported by the graph. The graph of mass of cathode is directly proportional to the type of electrolysis. In this electrolytic cell, the magnesium strip that connected to the positive side of the power supply acts as an anode, whereas the magnesium strip connect to the negative side acts as a cathode. The magnesium nitrate solution is an electrolyte that conducts the electricity from one electrode to the another. When the power supply is on, the current is flowing. Oxidation happens at the magnesium anode, adding the magnesium ion to the solution. Those magnesium ion travel on the electric current to the cathode, where the reduction is occur at the cathode, letting the magnesium ion onto the cathode. The observation in this experiment is the anode become the thinner and cathode become thicker, and the silver solid is coating at the cathode, and also the effervescence is occur. Effervescence occur is because of the hydrogen gas is produced at the cathode based on the half equation. In this experiment, the cathode have the two half equation. One is the Mg convert to the Mg2 positive, and one is the forming of hydrogen gas. This is because this experiment is the non-ideal experiment. From the experiment, we can know that the time of the electrolysis increase, the mass of the cathode also increase. This can be proven by the graph or the mass of cathode against the time of electrolysis. In the graph, the R square value is 0.995, which shows that the directly proportional relationship between the mass of cathode and the time of electrolysis. There are some sources of error occur in this experiment. First, some of the magnesium deposited at the cathode may break away from the surface of the cathode and fall into the bottom of the beaker. This will reduce the mass of the magnesium cathode deposited at the cathode that is recorded in the experiment. Next, when drying the cathode with the tissue paper, some magnesium may be removed from the surface of the electrode.
Lastly, conclusion from this experiment, we find that the mass of cathode before and after of this experiment is different. This is because electroplating occurs where it is processed to create a metal coating on a solid substrate by using a direct electric current to reduce the metal cation. So the higher the time taken, the higher the mass of metal that coating on cathode electrode. That's all from us. Thank you.